Hi, welcome to Seegrid's presentation for Simio Sync 2025. We're going to dive into flexible simulation for optimizing Seegrid's AMR solutions. My name is Sydney Schooley. I'm the Manager of Application Engineering here at Seegrid. Later you'll hear from my counterpart, Sophia Penegopoulou, who's an Application Systems Engineer. And for this project, we collaborated with Adam Sneath from Simio, who's a Senior Solutions Engineer. So who is Seegrid? We are an autonomous mobile robot, or AMR company. We automate manufacturing and distribution facilities for a multitude of customers. Seegrid prides themselves in creating partnerships with our customers for long-term success and safer material handling solutions. We started in 2003 by Hans Moravec, who's a Carnegie Mellon grad, so we have strong Pittsburgh roots and chose a strong Pittsburgh company in Simio to go on our simulation journey.
There's a revolution happening in material handling, from manufacturing to logistics and warehousing. The future is autonomous. And at the heart of this revolution is Seegrid. Supporting more than 50 global brands, we continue to deploy our trusted and proven AMRs in live customer environments, completely transforming the way these facilities operate. Imagine manufacturing environments running as many as 100 AMRs inside a single facility, handling almost 80% of their non-conveyed material moves. Our customers experience significant labor savings and productivity improvements, often generating an ROI in far less than 18 months and reducing inventory levels inside the facility by more than 30%. We successfully automate mundane material moves, removing the need for some of the highest turnover position in facilities today. And we're doing it all with safety as our top priority, as seen by our 0 reportable and recordable safety incidents to date. Seegrid revolutionized infrastructure-free navigation several decades ago, built upon our stereo vision and 3D mapping technologies, and we continue to lead the way with automated material handling innovation. In the next series of videos, we'll explore how our pioneering technologies continue to add real value to our customers today. As industry innovators, we'll continue introducing new and improved technology to enable our customers to automate more than ever before. Join us as we dive deeper into workflow automation and explore the advanced innovations that are shaping the future of our industry. The journey has just begun, and the possibilities are limitless.
Why use simulation? So the Seegrid application engineering team is part of our sales department. We create the technical solutions that our customers are going to implement. For years, we've been using an Excel model. It's tried and true. This is the way we've been doing it, and we believe in this method. We create a route in CAD and then extract that to marry that with our speed profiles using an Excel macro. This way we get to gain an accurate picture of what the AMR cycle time is and how many AMRs we need to complete the solution given the volume provided by the customer. Knowing that our product has grown more and we are seeing more complex workflows with our customers, we knew we needed a different tool in our tool belt, hence discrete event simulation. It helps us better understand and visualize AMR interactions at key junctions to reduce congestion, such as where travel paths intersect. How many vehicles are intersecting at once? Am I creating a pileup? How can I reduce material exchange time? And that visual is very impactful for my team. Diving a little deeper into the Excel model, we will use this to make sure we can quickly arrive at an AMR fleet count, to tell our customer how many vehicles they are going to need, compare changing material exchange time and how that affects the fleet count. For instance, does it take 5 minutes to exchange this cart? And do I need the same amount of vehicles as if that exchange time increased to 10 minutes? We'll also compare how changing volumes affect the AMR fleet count. For instance, if the customer has average volume throughout most of the year, but then a peak at Christmas, can we still use the same vehicles to help them at peak time? As well, we'll compare how added route behaviors and zones affect the AMR fleet count. So if I need to create a slow zone in a specific area because there's a break room, or I need to create a fire door zone to integrate with a customer's fire alarm, we need to add those in here to account for that. Then looking at simulation. Again, another tool that will help us get answers to key questions and set up experiments so we can find those answers. For instance, does the solution over time see major traffic jams at intersection 10? Does this add significant time to our cycle time? How can I reduce this traffic jam? This is more problem solving on the application engineers to see how is this solution being done and how can I help it? How well did we keep up with production volume with 12 AMRs? We can easily set up an experiment using Simio software to see what if I looked at this specific workflow with 12, with 13, with 14 AMRs? How utilized are they? What is my vehicle count for that? However, looking at Excel versus simulation, we don't always need to use Simio simulation for every opportunity. Like I mentioned before, my team is part of the sales process. So sometimes we encounter very quick deadlines to get an answer to our customers. Our Excel model is best to do that as compared to simulation. And it's the main key differences are our Excel model, you input the data, here's the AMR fleet count. Simulation, we're gonna input the data and guess and check at the AMR fleet count. So it's a different process, but our complex workflows are best used with simulation. Setting the stage, single presentation of parts is a common workflow we see in manufacturing material handling. Often in manufacturing floor, space is at a premium. You might change your process, your setup, but you're still in a predefined space. So with many parts that need to be added to a product, you often see one container of that material, hence single presentation of parts. You might see two, but mostly one container. And then as industrial engineers, we know that a non-value added process is not what a customer is paying for, which is material handling. So if there's one container of parts that gets down to 0 in the container, the clock starts ticking for that material handler to exchange the empty container for a full in as quick amount of time as possible to keep production moving at a steady rate. And as you can imagine, if you have an assembly line of a car, there are hundreds of parts that are needed to assemble that car. So this poses congestion problems for the material handlers and also leads into congestion for automation as well. So how does Seegrid support single presentation? We refer to this as job sequencing, but in the manufacturing floor, you might hear it be called hot swapping, moving that empty for a full container. So for Seegrid, a job is what the AMR does. It's going to pick up something here and it's going to drop that same thing over here. And then sequencing those jobs, job A can't start until something happens in job B. So that way we are sequencing those jobs. So a process flow of job sequencing in manufacturing might look like an operator calls a container to be replaced through an integrated button press. That signal starts a job. We'll call it empty for full container for part 1, 2, 3, 4. Then the Seegrid lift AMR number 1 will pick up the empty container from the assembly line and take that to a location for empty containers. Then AMR 2 needs to pick up a full container from a staging area and place it in that same position at the line. However, AMR 2 will not start their job until AMR 1 has fully removed the empty container from the line. This ensures that the full container does not arrive before the empty, and we're minimizing the time that an operator is without parts at the line. In 2024, we began our journey to find a simulation partner for discrete event simulation, adding that other tool in our toolbox. We went with Simio because we saw that there was going to be a great partnership there. Highlighting on some of that collaboration, very specifically, when we needed to troubleshoot our model, it was great to have link labels turned on and off. It wasn't a feature previously in the software, but our developer worked with the Simio team to make sure that that was added in the next software release to make troubleshooting a lot easier. As well, we can't give enough praise to our developer, Adam from Simio. He created a positive collaborative environment. He was always interested in our product, interested in what we were talking about, made sure to understand what our actual problem was, and we felt really great about this model representing how Seegrid would do this in the real world. And then all requests were discussed for true need or want, complexity, feasibility, and we knew that this was going to be a good journey. And our goal wasn't to create a perfect model, but get a good model with a great partnership for the future.
I'm Sophia and I'm going to talk about the modeling approach. Starting from the model data, I'm going to describe the inputs and outputs that are required for the simulation model. So while setting up the model for each specific application, the following items have to be configured. First of all, the pallet throughput at each peak location, the AMR routes in the facility, which can be extracted from an AutoCAD file, the vehicle type, because the simulation was built around the characteristics of the different vehicle types of Seegrid, the number of vehicles of each type. This can be determined through an experiment section in the simulation, but it's good to have a general idea. The job process, which is the peak and drop locations, as well as the flow of the AMR tasks, and the battery type. This is optional if auto charge is needed, and it would help include the downtime due to battery charging. So once we add all these inputs to the model and we run the model, the following items can be derived. A visual simulation of the process flow of the application, the vehicle utilization, which includes on-the-job time, idle, and charging if applicable, the intersections traffic, which is a graph that shows the wait time per intersection, and the job times, which is the average time for each pallet movement of the application. This is an example model that we use a code name for Seegrid assembly plant. On the left, it's an AI-generated image of how this could look like, and on the right is the Simio UI that's showing the whole factory, and then the routes, and all the small segments you see are pick and drop locations that we are servicing. Moving on to some key model features. Job sequencing is the first one I'm going to talk about. So job sequencing is a Seegrid-developed feature that allows replacing a full pallet with an empty one, or the opposite, with dedicated full and empty put-away locations. The ability to do a hot swap with two vehicles allows us to work at time-critical applications and make the fleet more efficient. As we can see from the video, we have two trucks that are dispatching at the same time. One is going to the exchange location, picking the empty pallet and taking it to the empty storage space. The other one is taking a full pallet from the full storage space and taking it back to the exchange location. So we have basically exchanged an empty pallet for a full at the exchange location. Then both trucks go to the taxi stand and are idle until they get the next job assignment. Another model feature is the intersections. So bottlenecks can be created in the application and they cannot be easily identified without specific data. Traffic management is configured based on our fleet management software, and then using the Simio dashboards that show the wait times per intersection, we can identify the bottlenecks. As shown in the video, we can see that there is a specific point that many trucks want to occupy, so a queue is created. Here we can see up to 3 vehicles queue behind each other, which is completely fine, but looking at the simulation and then the intersection wait times, you can identify bottlenecks and potentially change the routes to avoid them. Some model capabilities. So multiple applications is a key model capability. It is often needed to scope multiple applications with different AMR types within the same facility. It is very helpful to be able to see the fleet orchestration and how the different AMRs will interact. In the 3D video, you can see 2 Seegrid vehicle types, the Seegrid tow tractor and the Seegrid leaf truck. They have different routes, they service different applications, but we are able to visually see and get the data for their intersecting points. It is often needed to scale up an application by increasing the throughput, adding more pick and drop locations, and therefore requiring more vehicles. In the example above, we can see the example Seegrid assembly plant application. Initially, we were scoping just a part of it, which is the rectangle on the top of it, and then eventually we had to extend the scoping efforts to include the whole factory. So from Simio, we had a baseline that we could build onto. Moving on to the model experiments, this is the way of identifying the number of vehicles. So you can run many scenarios in parallel, and you have to identify the number of vehicles per application. So here we have 4 applications, so 4 different vehicle populations. So you have to have an idea, or you can try a bunch of numbers, and then the output, which is the second picture, shows you the average utilization in percentage per application. So you have to have a rule of which utilization you prefer. You don't want to have 95%, you don't want to have 25% either. So you just pick the number of vehicles based on the utilization that you would want. After you select the number of vehicles, you can run the whole simulation, see how this is running, and then get the dashboard with all the results. Every project has challenges, and since there is little revenue in easy, it's our job as solution providers to overcome them. This is a quote by our CSO, David Griffin. We keep this quote in mind while trying to overcome our hurdles. The first hurdle that I'm going to talk about is educating the entire Seegrid application engineering team. So as always, it takes time to get used to a new process and work with a new tool. The timeline to how this progressed is initially we asked for team feedback during the development. So there was an initial release training that the whole team had to go through and give us feedback to make sure that we have useful for everyone simulation. Then during the way, there were changes to that initial release training. So we had to update documentation of the procedures, including troubleshooting needed for the team. We had to keep updating this documentation to include the initial release training as well as any modifications or additions to that. Lastly, there are multiple features that cannot be included in one application. So each member has to familiarize themselves separately to each feature and then be able to work to an actual application using them. The second hurdle is translating Seegrid fleet management into Simio. So Seegrid fleet management is based on years of software development and vehicle capabilities, and it had to be built in the simulation template. The key to overcoming this hurdle is to identify the capabilities that are needed. There is a balance between model accuracy and development time, because you never want to spend a lot of time to make the simulation identical to the product when you know you are not using all the capabilities of it. The last hurdle is keeping the model updated. So between the sales and implementation phases, the route might change. In Simio words, changing the CAD routes means updating the whole simulation. Now for Seegrid's business evaluation. So with Simio, Seegrid has entered a new chapter. The Seegrid's application engineering scope and capabilities have expanded with using Simio to model customer workflows. Our plan is to expand our approach to align with evolving business strategies. That includes adding more features, being able to support more workflows, and adding new products. All of the above lead to more of a need for simulation as the applications keep getting more and more complex.
To recap, we saw how Seegrid application engineers added a new tool to their tool belt for solution design and discrete event simulation using Simio. We also saw how a complex real-world problem and job sequencing, or hot swapping, is simulated in Simio, and we saw the great start to a new partnership between Seegrid and Simio. Thanks for watching.
Hello.
Good morning.
Great to see you, Sydney. You can hear me okay?
Yep.
Excellent. Well, I want to get started by saying excellent work. And thinking about this project, I'm sure a lot of people in the audience can relate to the fact that these projects are a journey, and it's amazing to see how much it evolved from the first call to where we are now. But I wanted to thank you for the kind words, and I also felt like the collaboration was really productive and efficient. It's funny, every month or two we would meet and say, this is going pretty well. So I think it was a really enjoyable process working with you.
Surprised at how well it went. Like, not that we thought it couldn't go well, but it's like, wait, we should be encountering more hurdles than I think that we actually did.
Yes, pleasant surprise. Well, we've got a lot of questions for you, so let's jump right into it. First question posted on the screen. So during the collaboration development process, can you speak about how deeply the Seegrid team was involved?
Yeah, so we formed a tiger team. Myself, Sophia, who you heard in the presentation, as well as Abby, who's on the screen right now. We are responsible for collaborating with Simio to help develop the model. And then throughout the process, once we felt the model was in a good spot, our whole team, including myself, is 9 people. We got everyone else more involved and had them go through our template model, our first one that we were doing, to see, did we miss something? We have 4 people looking at this, but we've been looking at it for a couple months. So what did we miss? And to get someone's first impression of going through this process that hadn't been intimately involved. Um, so we definitely had the experts on our team, but then making sure that the people who might use it further in the future were also involved at various points.
Yeah, and I'd say we met regularly, at least once a week, sometimes 2 or 3 times a week
Multiple.
as needed. So we were pretty plugged in. Yeah, and I thought it was interesting too that you had such a large group of experts on your applications and your product, some of whom had a little Simio experience, some who had very little Simio experience, and it was great to get those different perspectives and have those discussions about what should we include and just get everyone's perspective. We also got in person pretty early on. I think that was really helpful to spend a few hours together in person too. Great.
Yeah, we actually had Adam and another developer, Dan, come and see the AMRs. Given that we're both in Pittsburgh, why not come see the trucks? Easy enough drive, come to Seegrid for a couple hours. Feel like that could have been a unique thing for you guys to see the actual environment you're trying to simulate, versus just go, oh, I know this company maybe in general, but you're able to ask questions about the AMRs, and see kind of like the demo of what we were trying to simulate, at least with the template.
Yeah. Yeah, personally, I've really enjoyed being able to get back in person after, the past few years, more so a few years ago, but that's something we're starting to do more often is get some boots on the ground. All right. Let's move on to the next question. So, someone's asked, are data tables used to auto create the vehicle travel network?
Abby, do you want to take this one? And can
Yeah.
you introduce yourself too?
Hi, I'm an application engineer here at Seegrid. So we do use data tables to auto create the vehicle travel network. So like you saw in that video, the travel path can be pretty complicated, and it's kind of what's key to what we're trying to simulate. So Adam helped us use AutoCAD, which is already the software that our routes are going to be in, and then we're able to use a Python script that Adam helped us create that takes all of the route network from CAD and puts it into a Excel spreadsheet. And then we just upload the spreadsheet right into Simio, do the data connector, and then all of our routes are able to populate into the Simio model. It's super helpful because the intersections are already identified, and we put in some helpful stuff to reverse some of the orders of the segments and everything. So that way, some of the more basic problems that you might have coming in from the CAD are caught in that transition phase. So it's made it really smooth.
Yeah, that was another aspect that I was a little surprised at how well it worked. I mean, if you think of the science of it, you get Cartesian XZ or XY coordinates from the CAD and connect them with nodes. So it shouldn't be too complex, but after we started to roll it out and you came back with 3 or 4 models pretty quickly with different layouts, and I was just like, wow, it's cool to see how we got it. But the first step in the process is still manual, right? You draw the initial route over a floor plan you get from them, right?
Correct. And honestly, I remember this was like one of the most impressive parts early on, where I thought one of our biggest hurdles was going to be how do we get what we draw in CAD and the data we extract from CAD to put into Simio. I thought that might be the longest part of the process, and that seemed like one of the easiest parts of the process. I was like, this is going to be a good project. I think you figured it out actually before we officially went with Simio, just showing us that dedication that you're like, we want to work with you. And I was just immediately impressed because I was like, my perception was that was going to be the biggest hurdle, and it was not.
Yeah, it's funny. I'm like you, a sales engineer, and I remember saying at some point, "Yeah, I think we can do that." And I will admit, for those curious, that I'm not a high level programmer. Certain tools out there nowadays, I won't say any names, definitely assisted with creating some of the code, debugging it. So it was great that we were able to leverage that in a meaningful way, I thought. All right, let's see the next question. How do your end users add information to the model, like pick and drop locations, destinations, and arrival rates?
I'll take the first stab at this, and then Abby, if you want to elaborate. We're doing this manually in Simio, but we have already created the data tables and the template for how they're going to add that in. So there's no way for Simio to know where an application engineer has determined where a pick and drop necessarily needs to be, except for when we do a pick or drop, the vehicle is going in reverse. So it's looking for those segments that we've color coded. But we have various times with that as well. It takes us longer to pick from at height versus, at 15 feet versus just on the floor. So we need to input and have that already there for the user to say, this is a floor pick, this is a lane pick, a table pick, whatever it needs to be. And then we're creating those jobs within Simio as far as the destination goes. And then arrival rates, again, that would be volume information that we're getting from the customer that we're going to input into these data tables. But when we originally started this journey and how it is now, we want everything to be that a user could use a template, didn't have to recreate a data table within Simio or try to figure something out. They can just go, okay, this is my arrival table, this is my pick table, and add in appropriately what I need. Abby, anything else?
Yeah, a big thing with the arrival rates is warehouse environments are really dynamic. So the rate can be different times of day and across the different commodities that are being picked. So we call it the group table. We leverage different data tables within Simio to be able to easily change those arrival rates. And it helps both with the debugging that you can set it to like a pallet comes every 2 minutes flat and I'll know that, or have it be more dynamic using those different intervals.
Terrific. Yeah, that was one of the first requirements in my mind was creating those data tables. So it was pretty plug and play. And I think through some of the questions we have still coming in, we'll have a chance to elaborate on that. All right, let's see the next question. When routing changes are needed, are you changing this from CAD or in Simio?
I think
Abby, they're
we
just
should.
hesitating because we're trying to figure out who should answer. We can both it. So, Abby, you go ahead.
I think best practice for us is to change the routes in CAD, especially if it's like a bigger change. It's definitely easier to change those in CAD just because the nodes can be a little bit tricky. We were able to add a node label feature in Simio, which was really helpful in making some of these changes. So if it's something small, like I didn't connect a line in CAD, I'll totally just do that in Simio and then make a note to update it in the CAD later. But if it's something bigger, I usually go into the CAD, make that update. It's really quick to do the transition from the CAD file to Simio, so it doesn't really slow us down too much.
Yeah, when we were working with Simio early on, we knew that we were going to have to change the process for our team when we draw things in CAD. Naturally, we want to do things quicker, so we might use a block of a pick with a specific behavior from a previous CAD and drop it in there, or I don't have to worry about the direction of the lines. But when we're putting this into Simio, we tried very heavily and tried to look at different options for understanding the directionality of the lines so that way it wasn't a long process once you're in Simio. And ultimately ended up with we needed to be better about drawing the direction of travel within Simio to make or within CAD to make sure that it translates well into Simio. So anytime our application engineers are doing a model, it's okay, try to draw it correctly as much as you can in the direction of travel, put that into Simio and start troubleshooting. And if you have a couple lines, like Abby said, where you just need to switch maybe a couple nodes to change the direction, make sure your vehicles can move through the network, or if you're seeing, like, do that in Simio. And if you're seeing a whole bunch of problems, hey, maybe you need to go back to the CAD, maybe you need to take another look. And then we actually have office hours for Simio for our team, and they know who to go to as well. Hey, if you're troubleshooting, go to Abby, Sophia, myself first, and just have another pair of eyes on that and try to see where'd you go wrong. Because most likely it's something simple. Is anything major? You probably didn't have the line going in the right direction, so you create an impossible path because the vehicle can't go to the next segment. But yeah, so both. It's easier to do it in CAD and more sustainable versus doing it in Simio.
Yeah, it's fun talking through it because I'm remembering some of the challenges and approaches that we took. So, for instance, you alluded to the way that you draw the line segment in CAD has a direction implicitly. So when you click that line segment in CAD, there's a start X and Y and an end X and Y. So we were reading that. And we tried to put some tools in the template. So if there's a breakage, because it's easy to click two segments in CAD and think that they're connected, but they're slightly offset, we tried to put in, this was one of the input data validations, an easy way for you to see in Simio or hone in on where that is. I think something we developed later is we would just put a box or a pallet, one pallet in the network, no vehicles, and give it a start node and an end destination. And if the vehicle flies off in free space, you know there's a disconnect, and then you can kind of tune in to where that might be. So, yeah. All right. Next question, please. Okay, so this looks like a question probably from another model developer. So are you handling intersection control logic with resource seizes? And if so, during the table-driven travel network import, can you also automate intersection control logic and apply those processes to the required links or nodes? If you want, I could take a stab at this just as the developer.
Yeah.
And
sure.
okay. So the initial answer is yes. Resource seizes along with some state columns in a table. So at risk of going too much depth, I'll try and summarize. There's an intersections table with a key code, and we have, you know, overloaded 50 codes in there. So int1, int2. So you have these primary keys. And then when we're doing the data extract, we came up with a strategy to use a different color in CAD, like a blue segment to indicate the start of an intersection. So as it reads the data from CAD, it's basically mapping those codes to a table of links to say, all right, link 5, link 7, and link 10 are part of intersection 1 because it read these colors from the CAD. So exactly to the point of the question, we automated that mapping. I think on the first pass, we had the team manually doing the mapping. So going through the links and saying, okay, these are together as an intersection. And then the underlying logic of the model is when it pulls up, when you pull up to a node, it's checking, is this an intersection? What type of intersection is it? Act accordingly. So resource sees release is part of that to allow just one vehicle in at a time.
Yeah, so to summarize and maybe in less developer terms, we've automated the process by going from CAD, color coding it, these are our intersections, going into Simio, and then we can troubleshoot to make sure that that translated correctly. As far as the logic goes, we are trying to mimic how Seegrid's fleet management software considers an intersection. So Seegrid, the term intersection for us is just like a traffic intersection. You know, if you have a four-way, we want to make sure that it's I go, you go, first priority within an intersection. But then also whenever we go in reverse, that's an intersection as well. So as a vehicle is going into reverse and pick up a pallet, there's not enough space for our vehicle to possibly go around it, you know, if it's in a 9-foot aisle or something like that. So that is considered an intersection for us because we don't want to allow another vehicle into the space while another vehicle is picking.
Great question. And I have a feeling that there are some other folks out there modeling AGVs and AMRs. Let's see the next question, please. So the theme continues. What is the best practice in modeling paths? I use accumulating conveyors to model path congestions, collision detection. So I think this question is about the object type within Simio. So we use just the standard path object, and we have a vehicle speed. So travel time on a segment is a function of vehicle speed and length of the segment. We did put a small bounding box under the vehicle symbol to provide a little bit of spacing. But most of the travel is controlled at the intersections, right? Sydney, Abby, not sure if you would add to this. It seemed a little bit more like a developer question as well.
I don't have too much to add to it now.
All right, next question, please. We have a long list of questions, which is great to see. How does the intersection logic work? Yeah, anything we would add to this? We've talked about it a little bit.
I think we covered this in the last question because we kind of elaborated a little bit more than what was asked.
Hopefully, whoever asked that question is satisfied. That's a great one. So by the end of this project, how much time would it typically take from new facility identification to model built?
Depends on what you mean by model built. Because we know we can create the model fairly quickly. Just as far as making sure that the logic is there and vehicles can move through. I would say what's going to take a lot more time could possibly be troubleshooting. So, you know, me as the modeler going, like why isn't something working? Oh, it's this one segment that needs to be reversed, and then like, you know, troubleshooting that aspect. But even once it's there, the hurdles that we might see with customers of getting information accurate volume information. And this is part of our process in general as sales engineers that, you know, customers might be like, I don't know, it's maybe 10 pallets an hour. Okay, so we modeled that. It looks like there's a lot of vehicles that are needed for that, given how large the network is. Or you said maybe it's 50 or maybe it's 10. Well, that's a really large range for us to go off of. So garbage in, garbage out with a model, or like Abby alluded to, we could use different distributions for the volume. So is it a steady 10 pallets an hour, or is it uniform? Is it exponential? And that can really change what we believe the solution should be based off of that variability with volume. So I would say more of it's getting that accurate customer input. Um, so this could take several weeks, it could take several months. And knowing that this is not the only project one of my team members is working on, it's not that they are dedicated to that project and working on it 8 hours a day for weeks on end. You know, they have other projects they have to work on as well.
Perfect. Yeah, I have the list of questions. Somebody else had asked about the quality of customer data. So I'm glad that you addressed that. And yeah, it was neat that we put in sort of optional stochastic aspects. So you can put in a distribution, or you can put in an average and see how that changes things. So wonderful. All right, next question, please. Classic simulation question. How did you determine the appropriate level of detail to model the vehicle behavior? Was anything intentionally excluded, abstracted, assumed, otherwise?
I feel like this goes back to we talked heavily about how are we translating basically Seegrid's fleet management software, how we control the vehicles into Simio, and what do we actually need to simulate or what's just going to innately happen. So like intersection logic, I think really was just part of how Simio would naturally do it when it comes to intersecting lines and travel paths. It wasn't anything specific necessarily that Seegrid does uniquely. Um, I'm trying to think of things we Abby, if you wanna take this, I'm trying to think of things we excluded.
Yeah, the big thing that this makes me think of is something that we made sure to include was hot swapping. That's a big process flow that we do a lot where you send 2 vehicles to grab the empty and the full container, and that was one of those that, like, wasn't really default built into any logic, and we knew from the beginning that was gonna be really important to us, so we made sure to include that. I don't know if I can think of anything that we intentionally didn't include. Uh
Um, yeah, that was enough for me to think. So, Seegrid, with our vehicles, we say that, if you buy the Seegrid vehicle, you have all the hardware there, but you don't necessarily all have every single feature that the Lift could do, that the Lift AMR could do. For instance, stacking. That's a big hot topic within the AMR industry. Can your vehicle stack? Can they do this, do that? Which is in our current product roadmap to develop that feature. So that's not something that we built in here, or other features that are going to happen a year, 2 years down the line. We haven't put into Simio, but I do believe that we have the good base. And now we've been through the journey of how do we add things and working with Adam and knowing that we need extra support. So we knew that a complex, like Abby said, hot swapping, aka for Seeger job sequencing, that was a major workflow we needed to have in the model. However, once we look at future workflows, we'll have to add those into the model. So we weren't going to try to add everything and make it perfect. We just never would have simulated if we tried to make it perfect or have every single thing that Sager could possibly do in the future.
Yeah, I think we had some good negotiation on a couple things came to mind for me was acceleration and deceleration. So we left that out, but we gave you a parameter to experiment with vehicle speed. Um, that also could accommodate something like manual traffic. So if you have forklift drivers or people walking through the facility, instead of seeing the vehicles, they will stop. So one way to get after that is to, once you think you have your vehicle count, you can run, what if our average speed is 95% of that or 90% of that or 85% of that? Does that mean we're going to need another vehicle? Um, and then, some of the rotation when they do a pick or drop, we assumed, and correct me if I'm wrong, but I think we assumed that to be in the delay time for the pick drop durations. So you've done time study on the different types of activities, and we capture the rotation, things like that in the delay times, right?
Mhm.
Sweet. Yeah, and then some of the other aspects were just built-in features to me, like the no passing on paths. So our custom link object was set by default to no passing and things like that. So, I think we've got about 5 more minutes for questions. If you're okay to keep going, let's see the next question. What are some strategies you applied while ramping up and training the user group?
I think we got talked about it a little bit earlier, but we wanted to have a small key group do the initial development. So Abby had come from a previous company where she used another simulation software. One of the first questions she had when she was actually interviewing, I'm pretty sure, was, "Do you use simulation?" So she has been dying for an opportunity to do this. And then Sophia Penakapulu is our application systems engineer, so she is heavily involved with integrations of our vehicles with PLCs, APIs, WMS, things like that. So we try to hone in on our experts for the team, and then to ramp up and train the rest of our team. We wanted to get their feet wet, so give them all the information that we have and see what questions they have. They all were required to do the same model, and that way we had Adam come in and they're like, what questions do you have? Let's reduce the variable of everyone doing something different. Everyone do the same thing. And did everyone have the same issues? Is it something that you just have to learn and get used to? Or is it something we, need to improve for the model or for the documentation? And then as we developed the model further, Adam was amazing and created a 20+ page user guide. And then internally at Seegrid, we put that into our Confluence system so that way it could be easily searchable, and we try to split it out per section. Adam also made videos for us for initial training. So we put in the videos and said, here are the pages you can go to for this section for your troubleshooting. And then we're having everyone, as they're going through this, like, if you found something helpful, type it into the page that corresponds to that section. So that way we're not reinventing the wheel every single time. So I think that has really helped us. That our users initially were just like, we need the videos. We're visual people. We need that to initially go through this. But then once I'm comfortable, I need to search for it. Like, okay, wait, how do I do job sequencing? Let me just search job sequencing. I get everything else, but like, let me just search for keywords. And I think that was how our users wanted to be trained.
Terrific. Yeah, another aspect I liked. I remember we were meeting, we thought the template was in a good place, and we all agreed, let's be careful about how we do this. We don't want to just throw it out into the world. And I like that you suggested we form groups. I think we had groups of 3 or 4
Yeah.
the first week, and then a second group. So we sort of bucketed it out so we could be focused with it. And yeah, let's see. Maybe we'll do 1 or 2 more questions. I think we still have a little time. V and V, can you elaborate on the verification and validation process?
Abby, I've been talking a lot. Do you want to take this one? Or we can collaborate?
Yeah, we can definitely collaborate on this one a little bit. So once we make a model, there's a few verification validation things that we can do because we've experienced so many of these deployments in real life. So a big thing for us is you hit go, all the trucks are moving, and you can kind of see visually on the screen where they either pile up or where there's problems. And sometimes that's a really intentional indicator of like, oh, there's a problem here. But then sometimes that's more of, oh, there's a Simio problem here. And so that's always really helpful. We also went pretty hard on the reporting part of this. So we have lots of reports. A very helpful one for this has been an intersection-based report. So every intersection has its own graph that shows up on that dashboard at the end. And that's been super helpful for this validation part of this of just, is this what we expected? Is this an intersection that we thought might be a problem? Is it a problem? And so that's been really helpful to validate the whole system and make sure it's all flowing the way we think it would.
More on the validation process. So we chose some initial models where we actually had installed them, and we had done that vehicle count in our Excel model. So we did the model in Simio, and we compared that to what was the value that we had in Excel. And also, verifying, like, this was installed and we felt that the vehicles that we suggested were accurate. We felt very confident in this. Garbage in, garbage out with data. Like, the data was accurate. We felt confident in this. How does it compare to Simio? We made slight adjustments based off of that, but we wanted to make sure that, even though it's running correctly in Simio, maybe there are certain variables that we determine, such as speed, where it's like, oh no, we actually should adjust that for all of them, at least initially, because across 5 different models, we're getting a similar, if not same answer when this variable is this. So we tried to look at what we had done previously that we felt confident in, gone through the sales process to make sure that Simio was, the theory was also matching reality.
Perfect. Yeah, and the verification, which I always think of with the E, is checking for errors in the logic or in the model logic. I would do that continuously throughout development, and then the validation with the A for accuracy, that was very collaborative. So, well, I want to thank you both sincerely. Great presentation. It's been great working together, and we've got a fun day coming. So stay tuned. Thanks everyone in the audience as well.